Hello, my awesome chemists. We are continuing to talk about thermochemistry, and today we are going to talk about stoichiometry and thermochemistry. So remember, stoichiometry are calculations in chemical reactions where we can link one substance to another using moles, using the molar ratio, which we get from the coefficients in the balanced chemical equation. So when you link to stoichiometry to anything else, usually the link is through the moles. So let's read this problem together. It says how much heat is transferred when 9.22 grams of ethane, which is C2H6, in your body reacts with oxygen according to the following equation. So the ethane in your body reacts with oxygen. Looks like it's a combustion reaction. And it makes sense that it would be a negative delta H because a combustion would be exothermic, releases heat. And they give us the balanced equation. And they also give us the heat that is transferred, negative 1,559 kilojoules. So what are they asking? Well, they are asking if we were to use 9.22 grams of this ethane, how much heat is going to be transferred? So heat transferred is delta H, but they already give us the delta H. So what's the difference? What are they looking for? Well, when they give you delta H for a reaction like this, so if they write the chemical reaction balance and then they give you delta H, this is for the reaction as balanced. We call that kilojoules per mole of reaction, meaning that this is how much heat is transferred when you use 2 moles of ethane, 7 moles of oxygen, 4 moles of CO2, and 6 moles of H2O. So this amount of heat is transferred when, in terms of ethane, you use 2 moles. The question is asking if I only use 9.22 grams as opposed to 2 moles, then how much heat would transfer? So we would start with the 9.22 grams, and you would want to change that to moles. So 1 mole of ethane is 30 grams of ethane. And so right now my grams cancel and I have moles of ethane. But I don't want moles, I'm looking for heat. So I'm going to put moles of ethane here, kilojoules here because I'm looking for the heat, and I'm going to use this number here. So I know that negative 1559 kilojoules of energy are transferred when I have 2 moles of ethane. So I will put negative 1,559 kilojoules of energy for 2 moles of ethane. And again, that 2 comes from the equation. So my moles of ethane cancel, and I end up with negative 240 kilojoules, and that's my answer. You can write it as negative 240 kilojoules, or you can write 240 kilojoules released. Remember that negative just tells you that it's an exothermic process, that heat is released from your system. Let's look at the next one. It says how much heat is transferred when 147 grams of NO2 is dissolved in 100 grams of water. And they give us the chemical equation, it's already balanced, and they give us a delta H. And it looks like this one's also exothermic. So what are they asking for? Well, they're telling us that we have 147 grams of NO2 and 100 grams of water, and they're asking how much heat is transferred. So again, they're asking for delta H. The delta H they give us is for the reaction as written. So it's for 3 moles of NO2, 1 mole of H2O to produce 2 moles of HNO3 and 1 mole of NO. The question is asking, well, how much heat is going to be transferred if I use these specific amounts, 147 grams of NO2 and 100 grams of water. So this looks like it's a limiting reactant problem. How do I know that? Well, because they're giving me both reactants. So whenever they give you information about both reactants, it is likely that it's a limiting reactant problem, and you have to figure out which one's your limiting reactant, and that's the one that you use to get your answer. So if you remember, there are many ways that I can figure out which one's limiting me. So one of the methods is to start with one of your reactants and solve for how much you need of the other and see if you have enough of it. Another method is to start with both of the reactants and solve for how much you would produce of one of the products and see which one gives you less product, and that's going to be the one that is limiting you. Since we're doing heat calculations here, another way to do it would be to start with both and see how much heat I would get transferred with the NO2 and then with the H2O, and whichever gives me less heat transferred, that is the one that is limiting me, because once I form that amount of heat, then it stops, or that it runs out. So I'm going to use that last method here, but you feel free to use whatever method you like to find the limiting reactant, and that's the one that you use. So I'm going to start with 147 grams of NO2, and I'm going to convert that to moles, so grams of NO2 on the bottom, moles of NO2 on top, and the molar mass of NO2 is 46 grams per mole. So now I'm at moles of NO2, and then I'm going to go from moles of NO2 to kilojoules of energy using this value here. I know that it's negative 138 kilojoules for 3 moles of NO2. And so when I punch that in, I get negative 147 kilojoules. So that means if I were to use up 147 grams of NO2, I would release 147 kilojoules of energy. Now let's do the same thing with the water. So if I were to use 100 grams of the water, I'm going to convert that to moles first. 1 mole of water is 18.0 grams of water. That gets me to moles, and then I'm going to put moles on the bottom so I get rid of them, kilojoules on top, and again I'm going to use this value here. It is negative 138 kilojoules for how much water? For 1 mole of water. My moles cancel, I end up with kilojoules, and I end up with negative 767 kilojoules. So which answer is correct? How much heat is actually being transferred? Well, if I use all of the NO2, my heat release would be 147 kilojoules. If I use up all of the water, then the heat release would be 767 kilojoules. Remember that negative just means it's being released. And so which one is releasing less energy, is transferring less energy? It would be the NO2, this one. So after I use up all my NO2, I would have transferred 147 kilojoules. Those would be released, and then the reaction would stop. I have enough water to produce 767 kilojoules of heat, but that's not going to happen because my NO2 is limiting me. It's going to stop the reaction once that gets used up. So whichever gives you the less heat transferred is the correct answer. And again, that negative just means that it's released as opposed to absorbed. Let's try one more problem. It says when 3 grams of magnesium were burned, 75 kilojoules were released. What is the molar enthalpy of combustion of magnesium? So the first thought that I have here is I am given some information about a chemical reaction, but I'm not given the chemical equation. So I'm going to start by writing my chemical equation and balancing it. So I have magnesium. It's telling me it's burned, so that means I'm adding oxygen to it, and I'm going to form magnesium oxide. Remember, magnesium oxide is ionic, so you got to balance out your charges. So Mg2 plus and then O2 minus. Let's balance it. So we need 2 here and 2 there. And I'm given 3 grams of magnesium, and I'm given also that I'm going to release 75 kilojoules for those 3 grams. What is it asking? It's asking for the molar enthalpy of combustion. Let's think about what that means. So enthalpy of combustion, that means heat that is transferred when you combust, when you burn. So how much heat is transferred when I burn my magnesium? Molar means that it's for 1 mole. So the question is asking how much heat would be transferred if I had 1 mole of magnesium. So I know that there's 75 kilojoules for 3 grams. How many kilojoules would it be for 1 mole? So there's a couple of ways to do this. Let me show you some of these different ways. So I know that I have 75.0 kilojoules, and I know that this is for 3.00 grams. But I wanted to say kilojoules per mole because it's for 1 mole. So what I could do, I want to keep the kilojoules here, but I want to get rid of the grams. So if I put grams on top so that they cancel, and moles on the bottom, then when I cross out my units, I would get kilojoules per mole. And I know to link between moles and grams, I can use the molar mass. And I know that 1 mole of magnesium is 24.3 grams of magnesium. So my moles cancel, or I'm sorry, not my moles. My moles do not cancel. My grams cancel of magnesium, and I end up with kilojoules per mole. And so this gives me, I believe, 607.5. So 608 kilojoules per mole released. Let me show you a different way. I could say 75.0 kilojoules for 3 grams is equal to X kilojoules for 24.3 grams, because I know that 1 mole would be 24.3 grams, and I could cross multiply and solve it that way. Let me show you a different way. A third way would be to say, well, if I'm looking for kilojoules per mole, I can take my kilojoules and divide it by how many moles I have. So I could start with my 3 grams of magnesium and change that to moles. So grams of Mg here, moles of Mg here. 1 mole is 24.3 grams. And that gives me 0.12, oops, sorry about that. 0.123 moles. And then I would say, well, I have 75.0 kilojoules over 0.123 moles. And that would give me the 608 kilojoules released as well. So any of these 3 methods would work, would give you the same answer. Whichever you're more comfortable with, that's the one that you want to use. Have a great day, guys.